Hello, this is Mrs. Ringrose, and we're continuing our work with rational functions. But before we can go any further, it's good to take a step back and just look at some expressions and build those skills on how to multiply, divide, add, and subtract, or just simplify them by taking out common factors. Hopefully we can build on those skills because you know how to do these operations with fractions, and just think about it in terms of that. And let's get started. So if you are given an example where you need to do any of those kind of things, simplify, multiply, divide, the first step should always be to factor, because you want to get out those common factors, and so you have something that's a little bit easier to deal with. So one example might be x squared minus 2x minus 15, all divided by x squared minus 9. And the first thing, you want to do is factor. And so this factors to x minus 3. Sorry, actually, it looks like x plus 3, x minus 5. And then this is a difference of two squares, x minus 3, x plus 3. And you'll notice that I have an expression on top and an expression on the bottom, and those can just cancel. Because this is not a function or equation where we have to constantly worry about inputs and outputs, this is just an expression. This is totally legit. And so your final simplified expression would be this as your answer. Okay? All right, what about another example? If you were given maybe this, okay, and again, you're told to simplify. Probably what you want to do is try to factor. So it looks like the top I can factor out a 2x, and I'm left with x plus 5. On the bottom, that's a quadratic that hopefully can be factored. One of the factors is x plus 5, and then my other factor is 3x plus 1. Let me just double check that's correct. 3 times 1 is 3x squared, 1 times 5 is 5, 1 times x is 1x, 3x times 5 is 15x, 15 plus 1 is 16. Boom, I'm good. All right, and again, I have some common factors. I can cancel those out. So now my answer is 2x over 3x plus 1. Okay, so that's just some practice with that. Moving right along. If we were asking you to multiply rational fractions. Again, this is going to look just like multiplying fractions that don't have expressions in them, and that you multiply across. So that's why it says same rules for multiplying fractions, but simplify if possible. So again, probably what I would do is try to get this into factors first, because then maybe things can cancel out and you have less to deal with. So that first fraction, I can pull out a 3x, and then I have 1 minus x. Sound good? On the bottom, that's a quadratic that factors out to x minus 1, and then x plus 5. And then on this side, I have 3x is in the bottom. Can't factor that anymore. But on the top, probably 4 and 5, multiply to 20, but subtract to 1. Right, so it looks like those are the correct factors of that. And I could multiply across first if I wanted to, use a lot of the lead in my pencil, I guess. And all the factors on the bottom would be x minus 1, x plus 5, and then 3x. And then I can start dividing some things out. This is on the bottom, and this is on the bottom. This is on the bottom, and this is on the bottom. So now what I'm left with is 1 minus x times x minus 4 all over x minus 1. But wait, there's more. 1 minus x and x minus 1 look strangely familiar. So what I can do is actually factor out a negative 1. Because if I pull out a negative 1 out of that x plus x minus 1, if I multiply that negative 1 back into x minus 1, I'm left back with 1 minus x. And now these guys cancel out. And my simplified version would be 4 minus x. Or negative x plus 4. Either one. Okay. Now I have another example for you. So it looks like the first expression is in a fraction, but the second one is not. So you can always put this into a fraction form by putting the second expression over 1, and then you just multiply across like we did. So x plus 2, and I'm going to go ahead and factor this at the same time. Looks like a binomial squared pattern. No, actually it's not. I can't factor it at all. If it was binomial squared, the middle term would be 6x. So that is non-factorable. The bottom one on the first is a special pattern because I have 2 cubes. So the pattern for this one is x minus 3. And then the rest looks like this. And then these cancel. And then this is my simplified expression. Okay, so again, I'll give you a chance to practice that. Next, we have division. I have 2 examples of this. I think I'm just going to do one. If you want to try the other one on your own and see how it goes, let me know. It's going to be the same rules as if you didn't have expressions, which is keep, change, flip, if you've heard it that way. I don't really like saying it like that. I like to say multiplying by the reciprocal. That's the way I was taught. Okay, so I've changed the division to multiplication, and I took the reciprocal of the second thing. So let's see what I can factor. And the bottom is going to be x, and then x minus 6. Okay, so I'm just going to take a step back, make sure that all looks good. Alright, so this x can cancel with this x. X minus 5 cancels with x minus 5. X minus 6 cancels with that. Looks like all I have left is 7 over 2. So if you know how to factor, these are not too bad at all. Next example that I said I'm going to skip over. But if you want to write that down and give it a try, your answer should come out to be 2x minus 3 over 4x cubed. Oh, that looks like fun. You should definitely give that a try. Okay, the next thing we're going to talk about is addition or subtraction. I think this might be it, the final slide. Again, same kind of skills if you have, if you know how to find a common denominator. So this first example looks like they already have a common denominator. So I think the trick on this one is to remember to bring parentheses with the second guy if it's subtraction, because that minus wants to get distributed. So 7x plus 6x minus x squared all over x plus 6, which is 13x minus x squared over x plus 6. And if there was a way to factor and cancel stuff out, you should do that as well. That example looks like there's nothing to cancel out, but you can certainly factor out that x on top if you think that that would look more pretty. Okay, next example, again they have common denominators already, so there's not a whole bunch to do. X minus 15 plus 7 over 4x squared. X minus 8 over 4x squared. There's nothing to factor, so they have common denominators. You just add the numerators or subtract the numerators. All right, so now we're getting into some ones that are a little bit more fun because there's more stuff to do. All right, so if you're given an example where you don't have a common denominator, what's going to happen is I think, you should go back to possibly factoring, because that might help you know what it is you need to multiply by. X plus 1. Okay. So in the denominator of my first fraction, I have 2 3's and 2 x's. And in the denominator of my second one, I have a 3x and I have x plus 1. So what's going to have to happen is I'm going to have to multiply this first fraction by x plus 1 over x plus 1. Because I'm trying to get them to have the same denominator so I can add them together. The second fraction is missing another 3 and another x. So what I'm going to multiply on this one is 3x over 3x. That'll get me this. And once I have this, I have a common denominator, so I can add the numerators together, and I should be good to go. So I'm going to also expand the first one I'm looking at there. 7x times x plus 1 is going to be 7x squared plus 7x, and then I have plus 3x squared. So my final answer is 10x squared, not cubed, sorry about that, plus 7x all over 9x squared x plus 1. And then you can factor out an x out of the top. So I have 10x plus 7 over 9x x plus 1. Right? And then the same thing goes to the next one. You want to find a common denominator. I will walk you through the beginnings of that one, and then I'll let you try the rest of it on your own. So if I were to put this into factored form, I have 2x minus 1 minus x minus 3, x minus 1. Looks like they both have an x minus 1 in the bottom, so maybe what I need to do is multiply the first fraction by x minus 3 over x minus 3, and multiply the second fraction by just 2 over 2. And then that'll get you common denominators, so you can go ahead and subtract across. So this complex fraction is where I'm going to pick up tomorrow. Make sure that you feel reasonably confident being able to find common denominators and simplifying some expressions, and we'll go from there. Thanks.